Like all the senses of our body, hearing is both wonderful and extraordinary in the way that it works. The fleshy outer ear collects the sounds that surround us and channels them down the ear canal to vibrate the eardrum. On the other side of the drum, these vibrations are transmitted through the middle ear by minute bones. These are the only bones that stop growing soon after birth. An adult has ear bones the same size as a newborn baby. One of them is the smallest bone in the body. Known as the stirrup, it's about the size of a grain of rice. The stirrup rests on the oval window of the inner ear and passes vibrations through it. On the other side is something rather intriguing. Called the cochlea, it's a small, bony, spiral tube. It's the key to how we hear the vast range of sounds that we do. If we zoom right the way in with an electron microscope, we should see something remarkable. The secret of how sound is transmitted to the brain. They're rows of minute hairs, only a few thousandths of a millimeter high. As noise vibrates them, they send electrical signals to the brain, which we experience as sound. It's fascinating to watch, and we're about to see it happen. Take a closer look at these V-shapes. They are, in fact, clusters of 3 lines of hairs, which are part of a built-in amplifying system. Now, if we take a look below, we should see the rest of the amplifier. There we are. The hairs are sticking out of a cell underneath, shaped like a sausage. It's actually been possible to isolate one of these hair cells, so let's see what it does when we play it some music. You might recognize the tune.
1, 2, 3 o'clock, 4 o'clock, rock. 5, 6, 7 o'clock, 8 o'clock, rock. 9, 10, 11 o'clock, 12 o'clock, rock. We're gonna rock around the clock tonight.
The joint's jumping, literally. The excited response of these hair cells amplify the faint vibrations that arrive here from the outside world. And they do it so well that we can actually hear the sound of a pin drop. Unfortunately, from the moment we are born, one by one, hair cells start to die. And those that register high frequencies die off first. The damage here is where hair cells have failed. Because of the loss of these hair cells, by the age of 10, we've heard a greater range of sound than we'll ever hear in the rest of our lives. As we get older, some people continue to hear relatively well, but in others, so many of the amplifying hair cells have gone that they can only hear loud noises. Most cannot hear high frequencies anymore. So the sound of the New York subway, which younger people might hear as something like this, would instead be heard like this.